Start now, actually. So, welcome to the Q&A session, the second one. And if you're just catching up on YouTube, that's absolutely fine because I know that I put quite a lot of stuff up, so you might not have got through everything yet. I've had a question about back titrations, so I'm going to go over another example of one of those. And I'm also going to go over a one about errors, percentage errors. Oh, let's let Els in as well. After that, I can talk about percentage yield a little bit. I had a question about dot and cross diagrams, but actually, I think I'm going to just refer them to a YouTube video, so I might not have time to go through all of that. And at the end, I'm just going to do the prize draw. I found a way to do it. It's not going to involve a physical hat at all, because actually it turned out writing down like various different names 200 times was not in my morning plan. So I'm doing it with a spreadsheet and a number generator, which is the fairest way that I could think of. Okay, so I just want to go through a back titration example. It's just another one of these to get this idea. And I also want to mention that on the Hess cycle question that I covered in the last Q&A, there was actually a typo because I actually uploaded the wrong question. Basically, the temperature should have gone down, not up, by the same number of degrees. So the enthalpy change would have been the same. I had my enthalpy change as positive. It's actually negative in the example that I gave. So if you're wondering why it was a positive enthalpy change when the temperature went up, that was because basically the mark scheme that I posted, if you look at the mark scheme, the temperature is slightly different. So I'll adapt the PDF, but I might not get around to it today. All right, so back titrations, a Q&A. We've got an organic compound, and this is just a percentage by mass. This could go on to a different question, but it's basically the aim of this is just to get percentage by mass. So we just want the mass of nitrogen compared to the mass of the whole thing. We've got the mass of the whole thing. So everything else in this question is going to be about finding the mass of nitrogen atoms, basically, not N2, because it's not an equation. It's a compound containing nitrogen. You've got ammonia passed into 100 centimeter cubed, and so we've got a volume and a concentration. So in a back titration, it won't have a label on it. Okay, the question will not say this is a back titration. It will just be near the end of the paper, more challenging titration than usual. Only thing that makes it more challenging is basically instead of titrating ammonia with acid and we're done, we are reacting something, in this case ammonia, with a reagent, and then we're titrating the remaining reagent to see what's left over. So, and in fact, what they've done here is they've taken a sample and they've reacted it with sodium hydroxide. There's no information there about the numbers for sodium hydroxide. All it says is all the nitrogen was converted to ammonia. So I don't need to know how much sodium hydroxide there was. That's not relevant. Sodium hydroxide is just a way to convert it. And in the second year, when you do more redox stuff, you're going to get back titrations with redox examples. And what they will often be is, for example, turning all the iron into Fe2 plus so that you can then titrate it. So that's just a step to make the nitrogen into a compound that I can react. I don't need any more of that information. Then I've got the fact that I put that into a volume and a concentration of acid. Then we're taking out portions. So there's a relationship between this 100 centimeter cube and this 25 centimeter cube. And we're calculating, and we have a mean titer, so the volume added of acid. But that's the volume of sodium hydroxide. So this sodium hydroxide is finding out how much leftover acid there is. So This went in, this all reacted. This is a known excess. So it's an excess, but I know how much it is. I can calculate it. So let's work that out. I'm going to work backwards. I'll always start with the last piece of information. The last piece of information is the sodium hydroxide. So I can work out definitely the moles of sodium hydroxide. 15.5 divided by 1,000 times 0.1 is 1.55, 10 to the minus 3 moles. Now what that's telling me, it's a 1-to-1 ratio. And if you're struggling with the how you know, I mean, you can just write an equation. But I've got a few videos in my equations and formulae playlist that talk you through like how you know from hydroxides, oxides, carbonates, how many moles of acid without having to write the full equation every time. It's just looking at how many H plus. So I've got moles of NaOH. That equals the moles of HCl because it's a 1-to-1 ratio that are left over. So this is after I've reacted it with the ammonia. And also, that moles of HCl is in 25 centimeter cubed. So when you're doing a titration, pay attention to where that volume is. But the original volume of the acid was 100. So I just took a sample out. That's normal for a titration. Take a small sample so that I know how much is, so that I can keep repeating the experiment. That's why I take a small sample. So I'm going to take that and I'm going to times it by 4 to get the moles that is in 100. Now, sometimes the numbers are not so easy as 25 and 100. Often they are. Often they are more like 25 to 50. So you're like, okay, to find out how many moles in the big sample, just times by 10. If it's a weird number, then you would just divide by the volume that you've got, the small sample, and then times by the volume in the big sample. So what I mean by that is, for example, if you had 20 centimeter cubed out of a 250 centimeter cubed sample, that isn't a very nice, easy to see ratio. But if you've got the moles in 20 centimeter cubed, to scale it up, you would just do the number of moles times 20. No, other way around. Times 250 over 20. So it's almost like you find the moles in 1 centimeter cube and then you times that by 250. Okay, but this time it's times it by 4. I'm actually going to rub that out because I feel like if somebody paused the video, they'd be confused as to why that was there. But I did have somebody ask me what to do when it's not an easy ratio. So you do that, you times it by 4, and that gives you 6.2 times 10 to the minus 3 in 100 centimeter cubed. Now that's what there is after reacting with the NH3. So now we can take, and we could have done this at any point. Lots of people do this at the beginning of the question, which is fine, so long as you know why you did it, because otherwise people tend to then want to do something with that number straight away. I can't do anything with that number until I use the titration results. So my top tip for titrations, always work with the last piece of information, which is the titer volume and what that titer and how many moles there are. Because that was the whole point of doing the titration, was to find out an unknown. You can't start at the top of a titration question and work your way through it. You have to start at the bottom and work your way back. So here, that is 0.0225 moles of HCl. So that's what there was in the beaker before we passed the ammonia through it. Now I'm going to find the difference. 0.0225 minus 6.2 times 10 to the minus 3. So that's the moles that I had at the start. Take away the moles that was left, and I found that out through titration. That gives me 0.0163 moles of HCl. If I look at my equation, get rid of all the stuff I wrote all over it. That's there. That's a 1-to-1 ratio. It's not always a 1-to-1 ratio, so make sure we go back to the equation. 0.0163. So it means that my sample, my original sample, produced 0.0163 moles of ammonia. Ammonia has the formula NH3, so there's one nitrogen in every ammonia molecule. So that means I have 0.0163 moles of N, just N. Another question I get, let me just let Marcus in, is like, what's the difference between like when should we use N2, nitrogen gas, like as a molecule, and when should we just use N? So if I'm doing a formula of a compound, I'm actually just finding out moles of individual atoms of something like carbon, hydrogen, oxygen, nitrogen. If a question said how many mole, what volume of gas is 0.0163 moles of nitrogen, and if the question said nitrogen and it was talking about nitrogen gas, that's when I use N2. The element nitrogen is N2, but this is part of a compound. Okay, I would then just times that by 14 because that's the atomic mass of nitrogen. That tells me there's 0.228 grams. This is a good point to decide whether I've made any mistakes because I am hoping that there's, less than 1.19 grams of nitrogen in the sample because the whole thing weighs that. That seems like a sensible mass because there's also carbon and hydrogen in the sample. So I'm therefore not expecting anything really big for my mass of nitrogen. And then percentage, we're just going to do 0.228 over 1.19 times 100 to get a percentage. I realise that's probably underneath my head on the recording, which is 19.2%. Okay, any questions on that one? So that is one of the most typical types of back titration, is simply taking something, usually a base. Sometimes it's a redox reaction. You react it with an excess of something. You know how much excess you have, and then you titrate the chemical that you reacted. So instead of titrating the ammonia, which you can't really do because it's a gas and you can't just like titrate a gas, you can't make a solution of it easily, we're reacting it. Other examples, insoluble solids. I can't titrate an insoluble solid like a calcium carbonate because it won't dissolve in water. So I might have to react my calcium carbonate with acid and then again titrate the leftover acid. Redox examples, there are, for example, copper 2 plus. That doesn't get oxidized. So you can take some copper 2 plus, react it with iodide to make iodine, and then you titrate the iodine. Slightly different, that one. So instead of doing an excess thing, you are basically turning the moles of copper into moles of iodine so you can find out that one instead. Use your balanced equations and work backwards. Okay, I had a question about one of the errors, or one of the error questions. Like how do you decide which way round an error? So, and this is, I also wanted to bring this to attention. This was a multiple choice, so you got a good chance of getting it right. But it's often just a 1-mark question, maybe even more, in especially paper 3, practical based, where it says, what's the effect of this error? And what most students do is give a really non-specific answer and get 0 marks. For example, they say it would make the titration volume different, or it would affect the results, make them less accurate. You have to be a bit more, it's the same as if a question said, what's the effect on rate? What's the effect on equilibrium? You've got to put your money on one side. Okay, you've got to say what happens to it. Sometimes you have to numerically say what happens to it, i.e., it doubles or it halves. Now, in this situation, I can't predict that kind of thing. But if I had a graph or something, I might be able to. In this one, though, I want to just talk through what the different options are. And the way to do it is to look at how you would use the results to calculate your answer. So although you're not being asked to calculate something, normally it's part of a bigger question where you are maybe doing a calculation. So it's often at the end, you've done a calculation and then it says, student makes this error. What effect would that have on the number that you just tried to work out? So always make sure with a titration, you take a moment to see which way round things are. So, but, acid is in there and alkali, sodium carbonate is in there. And then, we're just doing a titration to find the concentration of the acid. So this is my unknown value. And we put the acid in the flask. I can never draw pipettes by putting in a bit of that. Using a 25 centimeter pipette, and obviously we're finding the volume of the alkali. So if I was doing this, I would do moles of alkali. I was doing the calculation is volume times concentration. Obviously, do all the divide by 1,000, but that's it. So the moles of alkali depends on the volume in the burette, and then the concentration of the acid is going to be moles, which is going to be related to the moles of alkali, over the volume, which is related to the volume in the pipette. So we have 3 possible things that could affect the concentration that we calculate. One is the volume in the burette. That's how much we're adding. One is the concentration in the burette. If that's wrong, if that's different, we're going to assume the wrong number of moles for the alkali. And then the volume of the acid. So those are the 3 variables that if I change them, could change the number that I calculate. So bubble in the pipette, that means that this volume down here is too low, the volume of the acid. I thought I made 25. You look at the line on the pipette. If you're not looking at the bottom and there's a bubble in there, you haven't really got 25. So I'm actually putting in 25, but I've actually got less acid in there than I should have. So that is going to make me think that the acid is actually less concentrated. So that was the right answer because it's going to give me less moles of acid. I think I've got 25. I've actually maybe only got 23. That's going to result in less moles of alkali, but I'm going to be dividing by 25 because I don't realize that the real volume of the acid is lower. So that's why it would affect it. If I have a bubble in the burette, which is a really common question because it's a really common thing to happen, it's really hard to get the bubbles out the bottom, then what's going to happen there if the air comes out is it looks like I've added more alkali than I have. So that's going to give me a higher concentration of acid. Basically, if some of what's coming out is air, instead of needing, say, 25 of alkali, maybe it looks like I needed 27. So the volume that I put into that calculation means my moles of alkali gets bigger than it really is because some of it was actually air. And therefore it makes it look like the acid was more concentrated. Distilled water, no effect. Okay, the flask, you can rinse the flask with anything that doesn't react with acid because the flask doesn't measure any volumes. The pipette measures the volume, in it goes. If there's water in there, I could fill that flask with water if I wanted to. All it would do is maybe make my indicator a bit more dilute. I could put the acid in. It's still the same number of moles of acid if I've taken it in a 25 centimeter cube pipette. And so therefore it will still require the same number of moles of alkali. So that will have no effect at all. And then rinsing with distilled water, rinsing the burette, that is a problem. The burette is a volume measuring device. So if I rinse it with water, then the water gets stuck. It's very hard to dry out a burette. There's always going to be something down the side. Then when I add the alkali, that's going to dilute the alkali that I add. So the whole idea was I had a known concentration in the burette. It's not a known concentration if there's water in there. I've messed it up. Okay. Percentage yield. I think without an example, my main advice to you on that one is to write out the formula for percentage yield, which is either going to be the actual mass over I'm just going to write maximum mass times 100. Or you could also do it with moles. So then when you look at a question, because sometimes it's just they give you the actual mass and the maximum, that's very rare. What would normally happen is they give you the mass of a reactant and then they give you the mass of a product and you convert between them, i.e., so let's say that I had X plus Y goes to Z, and let's say that the MR of X is 50 and Y is 25 and that is 75. And if a question said that I've got 25 grams of that and I make 25 grams of that, what is my percentage yield? So I've got to do this one of two ways. I either use 25 as my actual mass, so that goes at the top, in which case I then need to work out the maximum mass using moles. So that is 0.5 moles. I'm just deliberately choosing nice, simple numbers. 0.5 moles of X will make 0.5. Check the ratio in the equation. So 12. What am I doing? You can't make. Oh, yeah, sorry. 0.5 moles. It's moles. Pay attention. Not enough coffee this morning. 0.5 times 75 would be the maximum mass that I could get out. Put it in, and it would be that over that times 100. But can you also see that the question could have said what the percentage is, and then you just put that value there. Alternatively, if you want to do it the moles way, do 25 over 75 to get your actual moles, and then do 25 over 50 to get your, so actually that way would be 0.33 over 0.5. That's your actual moles of Z, 25 over 75, divided by what the maximum could have been, which is 0.5, because that's how many moles of X you put in. When you have multiple steps, then you just keep multiplying the percentages by together. It's a bit like probability stuff where you have to work out the probability at the end of like a little sequence of things. So if you had two reactions and the first one was a 40% yield and the second one was a 25% yield, you would do 25% of 40%, which ends up being basically a quarter of 10%. So it goes down. Any more questions before I try the terrifying options of like trying to work this price drop? It's not terrifying. I've got faith in Excel. It's more in my screen sharing abilities. If you've got a question, chuck it in the chat. Now's your time. And let me just talk about that's a bit I just copied this from. So can we do an ice table question for KC? Well, I don't have one right on me right now, but do I have any examples anywhere else? I think I might do. Um, I think if I tried to like dig one out right now, I wouldn't be able to. Whether there is a KP video on my channel, which is like more challenging equilibrium. I think it's got KC in it as well. So, but every time someone asks me this, I think, yeah, I'm going to make a YouTube video on that. And then I get really busy doing all the exam prep and revision classes. So I apologize, as any one of me. Um, so I'm going to go on with this. And then I might try and like fabricate an ice question at the end or find one once I've got my windows open actually. So I don't actually know from my spreadsheet who's in year 12 and who's in year 13. I'm pretty sure I've got majority of year 13. So what I'm going to do instead is just pick, when I get to it, I'm going to pick 2 gold medal winners. I'm going to find a year 12 on my list later to give free A-level online masterclass subscription to as well. So I'm going to draw the bronze medals first because there's 10 of those, and then I'm going to take them off the list, all the names. So once your name has got a prize, you get off the list. Because, you know, otherwise some people would just be winning all the prizes. The more things you've been doing, the more times I've tried to put your name on the list. It's not an exact system, but say, for example, if you've done 90% of the course, then you've got 9 entries plus anything extra that you did, like emailing me, coming to the live sessions, or like commenting on YouTube, that kind of thing. Okay, so bronze. I've got 10 sets of predicted papers. They're not ready yet, but they will be free to these people. And if these people are in year 12, then they can either get the calculations and extended response booklet. They can have the predicted papers if they prefer and just keep them for next year, or a month free of the masterclass subscription. So I'm going to open. I have a number generator. I have a spreadsheet which has, at the moment, 204 entries. That doesn't mean 204 students, because some people have got their names, as we just said, like multiple times. And so I'm then going to do a random number generator and see who it is. And then let me just move on to that so I can make a note. The reason I'm not screen sharing is because this has all your names and emails on it. So, like, for GDPR reasons, I'm not going to do that because that would be really, really bad. Right, can I just please open up the actual, sorry, it's because it is. Do you know what? I don't need to screen share that, do I? It's gonna make my life a lot easier if I turn off my screen share for a moment. And I will make a note of the winners and bring it back in a minute. Woo! End price show. I told you that this was going to be a bit like stressful, didn't I? Oh, for heaven's sakes. End show. Yeah, there we go. Right, okay, I'm ready. I'm going to do this a bit more efficiently now. So we have a random number, please. Google. Google, give me a random number between 1 and 204. Generate. It is number 60. So the first person to win a bronze medal, let me scroll up to 60, is Evie. And it says Evie Noding. Okay. So I'm going to put you down there as a bronze winner, Evie. And I will find out if you were year 12 or year 13. So you win a set of predicted papers, and then we will get rid of all of those and get another number. Let's have another one, please. 132. Okay, 132 is Natalia. Um, you've got a number 12 in your Gmail, just in case you're wondering that's you. I will email the winners as well. So, Natalia, you are one of my second bronze winners. Next one, let's keep this moving and randomly generate another one. Next one is number 53, and that is Emma. Well, actually, I think Emma Norfield might be the parent name, but it doesn't matter. And that is another bronze winner. Take you out of the rotation. Let's generate another number. It is number 200. So keep it moving. And that is going to be Zainab. Okay, Zainab is my next one. How many have I had? 4. Let's keep going. So, woo, let's go again. Generate 58. That is going to be Georgia. Georgia is a bronze winner as well. I have made a note of your email addresses. 95 is the next one, and that is somebody who has put their username helpfully as hello. Thanks for that. However, I do have your email address as well. 152 is the next one. Scroll it down to 152. It is Shayla. Well done, Shayla. You're actually on the call as well. And you have won a set of predicted papers. And how many have I got now? 1, 2, 3, 4, 5, 6, 7. 3 more. Let's go. 150. No, it's the same number as it did before. 137. That is Rolnsey. I'm confused. It's somebody from Heddingston School with an email address, username that I can't pronounce. 180. It's like got an N. Rolnsey. Okay. Next one down is 180, which is Veer. Veer also wins a set of predicted papers. That is my bronze. I've now got 4 more things for the silver medals. Silver medals are going to get not just the predicted papers, but also the mark scheme, walkthrough videos, and everything else that goes with that. So the whole masterclass package for all of your revision for exams. If you are in year 12, you will just get the full masterclass package and a set of calculations and extended response booklets. So that is Boz, who is actually called Isabel, I believe. She has won herself one of the silver prizes, which is a full set of masterclass packages. Then we have, oh, now we're going up even further. Somebody whose username is B3 Aurora. You are a silver prize winner. 2 more. I have number 7, Aranima. You've got yourself a full masterclass package with the predicted papers and the walkthrough videos. And then 175, this is my 4th, got a silver medal winner is Tanisha Davies, which I think is actually Natasha Davies. So you are a silver winner as well. Okay, so I'm going to pick 2 gold winners. The gold winners get a place on a free exam prep, so a live class place for the three paper one, paper two, paper three exams. And that is going to be dun 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 164 Thomas. So somebody like your username is like 18089 in it. Thomas, you have won a place, assuming you are either OCR or AQA, so that it actually works in those three separate live classes, as well as all the other stuff with the predicted papers as well. And then the second person who's won that is I feel like I want to like be able to put this person's name out and go, oh, this person's like really, really amazing. Um, well done them. I mean, obviously they just like did the prize draw, but I don't think they've actually given me their name. They've just like given me the name Zed. However, that person, Zed, is a student at Bournemouth School. So they will get an email. If anything happens and any of these people do not respond to their emails or do not in any way sort of like or don't want their free prizes, I'll do a redraw and I will email those people as well. So well done, all of those people. And well, also, hopefully, even if you didn't win anything, you will actually have still want stuff in terms of like improving your chemistry. Let's see if we can. Oh, I didn't want to go all the like way through that. I just want to tell you what those people did get. And the fact that if you didn't win anything, some of this is just available for like a fiver anyway. So it's if you wanted more practice, so the practice calculations that we've been doing, bronze medalists and silver medalists and gold medalists, so you've won these anyway. This is all part of the package. But if you wanted more practice calculations, then this booklet is with the extended response booklet, which I use for my exam practice questions. These are £5 for the both. And with that, you also get your full A-level masterclass package voucher anyway for a 3 month subscription to that. The A-level masterclasses are for Edexcel, AQA, and OCR. They're recorded lessons. There are at least 22, some of them have 23, but they also have last year's predicted papers and exam walkthrough and the walkthroughs for those. So they have a full set of practice exams as part of them. And as I said, this is just £5 a month anyway. You get lots of other practice questions and you get the calculations extended response booklets, and you also get an entire calculations course. So if you're in AS and you just really want to work on your calculations, that's a really good way to do it. It's really stepped through every single type of question, like percentage yield, the lot. And if you're on any of my Easter courses or May half term courses, you get access to all of this anyway. It's always included. The 2025 predicted papers, because I know I'm going to get asked, they're not out yet. Give me a moment. So, paper one and two are mostly done for AQA and OCRA, but I just, don't want to have mistakes in them, and the walkthrough videos take a little bit of time as well. So I'm hoping to have those released in the next 2 weeks. It might be a situation where I release papers one and two, and then you have to wait a bit for paper three. But it is currently like 8 weeks until paper three, at least. Is it more than that? It's more than that. It's 2 months till paper one, and then add another couple of weeks for paper three. The gold winners, what you've won there. This is last year's dates because I haven't updated it, but it will be just before the exam. I'll be doing another hours class for each exam, paper one, paper two, paper three, for each of those exam boards as well. Okay, so I did have a question for KC. Do you know what? I'm going to find a KC question. Let's do it. That's a mean KC1, but we could do it anyway. No, actually, cancel that. Control there. So if you are in year 12, you might not want to watch this unless you have already done KC, in which case you might be ready. Okay. So with ice tables, let's go for this one here. And work out what's going on with that. So yeah, let's do an ice table with this one. And script through and get myself a. Oh, I also wanted to mention free resources. Don't forget, there's loads of free stuff on the website. If you click on A-level chemistry resources. So if you're concerned and if you're worried about whether stuff is going to still be up, I've not got any plans to take down the Easter revision course. So you can go back to that as much as you want. And you can also join these other ones and they're always there as well. All right, let me just get a nice blank space that I can do a KC calculation for. I'm going to put it there. I'll just put it in the bronze winners bit, which is a bit mistaken, weird, but okay. Will it let me do that? It won't let me do that. Okay. I'd have to go there and do it. Audrey, Casey. Okay. Let's work through this together because I really feel like when people turn up to a live and they ask something that I want to give them that opportunity to do it. So we have a little example. One I've chosen completely at random and I don't have the answers in front of me. So we're definitely going to work through it together. So we've got a sample of CHClF2. It's in a container. It's heated. Then we've got equilibrium and a mixture contains what is left at the end. Value of Kc. So we have got 2 CHClF2. That side, C2H4, 2HCl. And then we know that we start with 1 mole of that. So I'm going to call that my initial ice. And one thing I'm going to do when it's... So one thing, this has units. It obviously says give units. So this definitely has units. Because it's Kc, always remember whether you're doing Kc or Kp. The units are going to be related to the concentration. That's what the C stands for. So I'm going to say ice cubed. And that is actually, just to remind me, to divide by dm cubed at the end to get my concentration. So these are going to be always in moles. And then this is going to be my change. So I have no moles of that at the start. Don't always assume that. Sometimes you do. 0.2 moles of CHClF2. So that is the thing that's I've got left at equilibrium. So that has gone down by 0.8. And I think most people get these wrong when they skip the change column and they try to do it too fast. In this case, that is going to go up by 0.8. So that's be that. This one is going to go up by 0.4. Happy with that? So, boom, boom, boom. Yeah. Oh, can I repeat who the silver winners were? Sorry, I've only just seen that. Can I do that? I'm going to get through this first because otherwise I'll have to delete it. So, it says I've got a new message, but it's deleted. Right. 0.2, 0.8, and 0.4. That's going to be my values for the moles at equilibrium. And then I just divide every single one of those by the volume because I need moles per decimeter cubed. So the reason That one went down by 0.8 because I know the difference. That means it's the ratios in front that tell me that is the same as that. But this one here is only 1 mole. And so therefore, if that one went down by 0.8, that one goes up by 0.4. This is also really useful tactic for doing buffer calcs. So I do 0.2 divided by 18.5 is going to give me 0.0108. Do not round this number too much. I would leave it to 3 significant figures, even though we're going to do the last bit to 2 significant figures. And then I would go 18.5, 0.0216, and then 0.8 divided by 18.5 is going to be 0.0432. Then you just got to be careful when you put that into the KC expression because it has not given you the KC. Don't rush it again. We need to do C2H4 and then squared HCl. So it's going to be concentration of that 0.0216 times 0.0432 squared over 0.0108, which is also squared. So that needs to go to the bottom as well. Very good in terms of making sure that you use the top and bottom fraction thing in your calculator. And make sure you know where the squared buttons are, and make sure you also know how to do to the power of higher numbers like 4 or 5, because sometimes you'll get some really tricky balanced equations. I kind of put this in my calculator while I was talking. So I'm rather hoping it's correct. Actually, I don't even trust myself. I'm going to put it in again because I don't want to put the wrong number on a video again. So 0.0108 squared equals, I got the same number twice. I'm happy with that. 0.3456. That's nice, isn't it? But I'm going to change that into 2 significant figures, 0.35. Be careful of your rounding. Now, if I'd rounded everything up, I'm actually going to see, because some people are like, well, what happens? Do I get the same thing? So if I rounded everything to 2 significant figures, then on the top, I'd have 0.022 times 0.043 squared. And remember, 2 significant figures is not 2 decimal places. And then 0.011 squared. And let's have a look at what I get as an answer. So I get 0.336. So it is actually slightly different. It would end up being 0.34 if I rounded everything up a lot. So since everything's been given to 2 or 3, you would probably have a range in the mark scheme at that point. So if you had rounded, but what you really want to be careful is don't round to 1 sig fig, like 0.01, and then add significant figures. We'll just never round to 1 significant figure. It's really inappropriate most of the time. The units are just going to be moles per dm cubed, and I've got a YouTube video if you're confused about finding the units for Kc and Kp. I've got a really short little YouTube video that actually talks you through that. Okay, I'm gonna stop that share and just go back to my little list of prize winners, because so the 2 people that are the silver prize winner, oh sorry, the 4 people who are silver prize winners. There is somebody whose username is Boz, but I think her name is Isabel. There is somebody else whose username is B3 Aurora, who has a who appears to have possibly put their birthday in their email, but maybe not actually. Maybe it's just another date of importance. So I won't say that. Aranima and Tanisha Davies, who I think is actually Natasha. Just because I've chatted to her on email. And then the gold winners, someone called Thomas. That's all I've got for the username is Thomas. But I can tell you that Thomas goes to Maesteg school. I can't work out what that is. Maesteg school. They've got a school email address. And then somebody whose username is just Z or Z, and they go to Bournemouth School, according to their email address. So again, I'm not gonna like read out everybody's email addresses for hopefully obvious reasons. No problem. Thank you so much for coming, guys. I've got to go as well. I'm desperate for a cup of tea. And I'm going to go and sort out all of my resources for the OCRA course tomorrow. The silver one, the full sort of all the revision resources. So that's the predicted papers and the walkthrough videos and the masterclass subscription and everything else. Okay, cool. So thanks for coming, guys. And keep on working on your chemistry. Feel free to send any more questions in, and I'll try and catch up with probably a May challenge as well. Okay. All right. Bye bye, everybody.